Good morning, everyone. Last day, right, from a conference. My name is Jeff Sharpe. I work for a company called Supermicro. And you may or may not have ever heard of Supermicro, but we're in the top 5 of the leading server companies that are supplying compute gear, switching gear, heterogeneous systems into data centers, enterprise, telecoms. And I just joined Supermicro about 4 months ago, and I'm really excited. 2 things. One is that with a Supermicro perspective, and I'm not going to make this all about Supermicro, it's really about the industry, but you know, our focus really is cloud to edge. And my specialty really is how do we generate revenues with our operator friends, with our customers? How do we actually deliver products and solutions and services to the service providers themselves, not just to optimize their network, but also to monetize their network. You hear a lot of, throughout the sessions, throughout the week, you hear a lot of things about 5G and where we're going with IoT, different platforms, different complex type systems that we have to manage from an orchestration, from a VNF perspective. For me, it's all about commonality. It's about using common platforms, common software systems, open architectures. You hear this white box, gray box, black box environment, but really it all revolves around how the network is transforming at the edge, working with the core, working with the cloud, all together. And again, it's really all around how do I optimize the network, how do I use virtualize and container services, really to deliver applications much faster for the customers. And it's all about quality of experience. And the operators have always been heavily reliant on a lot of the big tier 1, the Nokias, the great companies like Nokia, Huawei's, Ericsson's, Cisco's, and all that. However, they're now having the ability to set their own path. There's challenges, and then there's also opportunities. And throughout all of these sessions that we've sat through and all the lectures and all the booths that you've gone to, it's all about how do I take all of these different network elements, virtualize it or containerize it, things for high throughput, deep packet inspection, load balancing. You hear about VoLT, you hear about PON networks, all becoming more and more virtualized. But that takes a lot of investment, that takes a lot of capital, that takes a lot of bump in the wire within the packets that are going across the network. And you also have security functions. So I have to be able to manage my network securely because I've kind of opened it up to more open architectures. I've opened it up to different application companies and services. And then, of course, with all the spectrum efficiencies that are going to come with 5G, the slicing attributes, the MIMO, the mesh networks that are going to happen, the integration of Wi-Fi networks, that's a lot of cost. However, where the revenue streams can come in are things like very low latency services. We all hear about autonomous vehicles. We all hear about AR, VR, things that you really need low latency applications. But they all have to work together really to monetize the network. So most of all, it's about how the operators can generate revenues and also deliver quality of experience and quality of services for their customer. I know this is an eye chart. Oh my God, it's a lot of words up there. But I like this because it kind of revolves around 6 key elements of edge computing and low latency services that are generating revenues for our end customer. Things like scaling, delivery of media services, and that takes transcoding, decoding functions, higher end video functions, especially the 4K. As consumers are starting to move off things like your traditional cable, they're starting to stream more services, they're starting to download more videos that are taking up a lot of bandwidth. By putting that at the edge really helps. Local connectivity, things like UCPE, a big thrust within the industry for UCPE gear, putting a lot of that gear as a managed services to our end customers. Broadcasting, compute, GPS, things that are really specific to that edge that provides very low latency. And with all of these services, all this text you see up here, you can't do it with just a plain Jane box. You really have to have a box that is heterogeneous in nature, multiple silicon levels, multiple types of facets that you can actually attach to a pole or be at that end site to the customer or at the radio tower. A good lead-in on a use case. So I'm all about use cases. I think, we talk cloud, we talk, VM, we talk OpenStack, but really it's all about those killer apps. It's really about the use cases that we all have to deal with, especially the operators. And in this scenario was a trial that we did last year in the city of Atlanta. Now, if any of you guys have been to Atlanta, oh my God, the traffic 24/7 is just horrible. And the city of Atlanta, the county of Atlanta, they knew that the Super Bowl was coming up. They have traffic congestion because of wrecks, all of this. So that what they wanted to look at is how do we utilize the carriers' networks to improve the way that we manage traffic, especially if there's an accident, a disaster, or whatnot. So if you think of all the different parties that have to be involved in this type of use case. You have emergency response, you have tow truck companies, you have first responders. You also have a network that I'm having to deal with the Department of Transportation, which is divided by the county, the state, and all this stuff. So I have to deal with that, and an operator is really the best integrator because they're offering the network for all of those functions. So imagine a traffic accident. And the trial also included a Ford Motor Company, and they had a new product within their car that showed the G-forces of an impact, not just the airbags going off, but what was the actual impact? Was it small, medium, large? Is it large enough to actually respond with an emergency vehicle? So think of this as there's a wreck that's occurred. It's during rush hour traffic. It's in a very congested area. So how do I manage the surrounding areas and respond very quickly? So there's an action response, decision making, who do I go, what do I go? All of a sudden I want to maybe manipulate the traffic signals to redirect the traffic to another area of the city. If it's severe enough, do I want to move a camera, take a drone to that location to look what's happening? If there's an EMT that's required, how do I get that EMT, that ambulance to that wreck to save people's lives? And the key part of this is we'd like to have that as being almost 100% autonomous. This is no human interaction or very little human interaction just to make some certain decision points. So using things like AI-based technology, DL-based technology, computer vision, things that we can actually look at the wreck itself and determine based on all these inputs coming in. And what better network to do that except for the communication companies? Within that radius, and by the way, how we worked on this was all the cell sites, we wanted to put a box at each five cell sites. So that's about a mile in diameter. And with that, having the same type of common platform mentality, the other thing that we could do is move not just from a GPU-based technology in this great use case, but we also, within that same infrastructure at the radio tower, we can do what's called ORAN. This is the Open RAN delivery that's happening through ONF, through the ORAN subcommittee. We're working diligently with some of our partners, Intel being one of them. And within this box, we have multiple types of boxes that we can put at that tower, especially in an IP65 enclosure, using what's called the latest Vista Creek silicon with Intel. It's called the FPGA PAC 3000. And what this does is it provides certain hardware acceleration that enables us to do the DU function for ORAN. And the key thing about ORAN, if you haven't heard about ORAN, is really opening up that last tower of defense of open radio access networks. This is CIPRI, which is normally a very vendor-specific protocol. And now we're moving to what's called an eCIPRI, which is more open in architecture, meaning that I can have companies like Supermicro to provide that hardware and a whole list of software providers to enable your DU and CU functions. And using the FPGA, going back to that whole common-based architecture, The FPGA PAC-N 1000 is really developed for networking functions, both at the edge and also at the core. It's really designed specifically for service operators, as a hardware accelerator, as a load balancer, as a virtual switch. It accelerates traffic. It has 2 NICs on it. It's like 100 gig support for low latency. And it also enables the customers to do a lot of customization of what they're doing. O-RAN's a great example. O-RAN's kind of our first entry point using this type of FPGA, and it enables us to program that. And using other partners, companies like HCL and others that enable the software stacks that enable O-RAN. We also hear a lot about ecosystem partners. I call them ecoskeleton partners because all of these products fairly have to be hardened, especially at the edge. So there has to be armor, there has to be a lot of functions to enable this to happen. Back with the N3000, we're looking at a ton of different use cases that can be used for the N3000 FPGA, not just at the edge, not just for 5G, but also 4G for your turbo FECs, for NFI and your core networks. How do I kind of accelerate some of those NFI functions? And if you go to Intel's booth, you'll see a lot of the use cases that them and HCL are putting together. We also have the card in our booth as well if you wanted to look at it. Another thing about common platforms and how we stumble into revenue generating cases using edge, especially intelligent edge with computer vision. We work very closely with a company that was specific into computer vision based technology, especially for the military. So during the war in Iraq and Afghanistan, there was a lot of bad guys that were trying to attack the bases. So technology was created using both CPU and GPU-based technologies in which you could look at the vehicles that are coming into the base, also the body language of people as they're talking to them, to analyze what are the risk factors of this guy being a good guy or a bad guy. And by basing these risk factors, it provides the troops a little bit of safety, a little bit of more questions on what's going on and why that person is there. So they're using body language, facial recognition, eye movement, voice tones, all put together, analyzed to say, is this a good guy or a bad guy? So we use that technology, and so we're going from a military, safety, making sure that our troops are safe, to a retail attribute. So with the retail attribute, we can use those same type of functions. We did this with an operator in the US for their mobile phone stores, that during that interaction between the sales guy and the customer, they can analyze at the end of the week why that customer left or why that customer bought that product based on the body language. Was his head down? Was his arms crossed? Was he looking? Was he smiling? Was he frowning? Was the tone of his voice going up and down? And this was all using intelligent cameras. It was using GPU-based technologies. And using this common infrastructure, the cool part about this was it was heterogeneous based on the silicon. So it's silicon agnostic, meaning I can use any kind of silicon from an NVIDIA GPU or a CPU or even a MIPS-based processor. My workflow would be the same, whether it's a military installation, whether it's a phone store, a mobile store. And then what this also led into is that they said, wow, it worked out so well for our mobile stores, let's make this into a service that we can sell and generate revenue for car dealers, for other retail stores and whatnot. Shift gears a little bit also on the edge. I'm proud to work with an ecoskeleton partner called ADVA. ADVA's here, and you've probably heard of ADVA as well. They're one of the world's leading software companies that are enabling both VNFs and containers to work simultaneously. They have a great product called Ensemble, And our focus the past few years with ADVA has been primarily on the UCPE business. As the IoT industry is growing, again, going back to this common architecture, intelligent edge theme, we can utilize this same type of software infrastructure on a common hardware infrastructure that can do not just UCPE functions, managed services functions, IMS-based functions, but also IoT from an industrial perspective, from a medical, healthcare, and retail space. And with ADVA, it's not just the edge box, you're also communicating back and forth into the cloud, both private clouds and public clouds as well. And the key part of what ADVA and Supermicro can do, we all know that virtual machines and containers have to coexist all within the market. And from an operator perspective, if you remember me talking about the challenges and the opportunities, the challenges, the big one is how do I manage all this stuff? I think that's one reason that NFV and SDN has kind of really shifted kind of to the right, mainly because of, God, I gotta manage all this. I really have to have the ability, do I go with a container? Do I go to it with a VNF? What's the throughput? What's all the issues around that? So ABBA does a great management system with their Ensemble and connector that we support on most of our systems. And from a risk perspective, for all your procurement guys out there that talk about risk, the best thing about having ADVA as one of our key ecosystem partners is that they've tested and onboarded a lot of software functions that are running on our hardware from all your key companies that are suppliers within not just the telco market, but also the enterprise market as well. So I just want to kind of conclude on, with Supermicro, we're kind of the Wizard of Oz behind the curtain. We're the ones who make everything happen. From a hardware infrastructure, we have great partners. And our focus really is from edge to cloud. Our key DNA is data centers. Our key DNA is large enterprises, large public clouds, Googles, Facebooks, Azures and whatnot, also big companies. And also within the telco, we're all in their data centers, but how do we move some of that data center technology to the edge? So having that spectrum of hardware from cloud to edge and using common building blocks to do so, not just with hardware, but software, is we're seeing a great advantages within our company and with our customers as well. So the key takeaways, the conclusions, again, we're still at the infancy of our network. Man, I've been saying that for 7-8 years within FESDN, but it's starting to take hold. We're seeing more and more trials. We're seeing more deployments at the edge, especially with hardened heterogeneous-based systems with multiple silicons. And it's really not about the cool hardware, the cool network elements that are behind, but it's really about the customer experience, the QoE. How do you improve how the customer does? That's what really drives our industry. The common platforms, again, from edge to cloud, using a common building block system that I can add GPUs or FPGAs or hardware accelerators, especially in the media side and on the Open RAN side as well as our key thrust. These systems have to be managed remotely, so they have to be hardened. You also have to have self-healing systems as well, knowing when they're going down and when they're going up, and being able to manage these containers and VNFs from cloud to edge. And also it's the building blocks for our mobile network. So thank you very much. Enjoy the rest of your show. Go see The Hague if you have time. It's a beautiful city, especially in the harbor area. I'm a boat guy, so please enjoy The Hague while you're here. And come stop by our booth and also our partners' booths with Intel and ADVA and others. Thank you very much.